All right, so without a doubt, we have from Mesosphere, he's got lots of energy. He's bilingual. Please welcome to the stage, Jörg Schott.
Thank you very much for the introduction, and welcome reInvent for this first afternoon session. And we'll talk about run everything as a service everywhere. I'll explain a little bit the buzzword hype, why there are so many buzzwords in this title. But first a question, how many of you have run Kubernetes so far? Anyone who hasn't heard of Kubernetes yet? Okay, that's what I thought. And this talk is basically about the difference between container orchestration. So this is what Kubernetes does really, really well, and that was actually the original design goal. So how can we orchestrate containers? How can we combine multiple containers? And then the kind of like next step is how can we actually do service orchestration? So how can we not only orchestrate individual containers or microservices, but how can we orchestrate stateful services such as Kubernetes, Cassandra, HDFS, Cassandra, and where are the challenges here actually? I'm Jörg Schott. I'm the technical lead for data science over at Mesosphere, so I'm building a lot of those service platforms. And I'm also part of the Cloud Native Foundation Governing Board, so also like from a Kubernetes side where we're discussing a lot how we can bring those services forward. And how I actually came up with this title for this talk, it was like looking at how DockerCon, how reInvent, and how all those other conferences developed over time. We started out by talking about individual containers. That was about like 2-3 years ago. As of right now, what we typically talk about is like container orchestration. How can we bring up our Kubernetes cluster? How can we use DCOS, Marathon to actually orchestrate all our containers? But for all of us who actually wanted to try out Kubernetes, I guess most of us tried out with Minikube. Who has actually tried Minikube before? Minikube is so simple. I just download a single binary, run that on my laptop, and I have an up and running Kubernetes-like cluster. But if we actually look at what it takes to run a highly available production-ready Kubernetes cluster, it looks a bit more complicated. So we have multiple instances for fault tolerance. We have our stateful store etcd up there. We have a bunch of kubelets up here. We want to make that all secure, so we want HTTPS connection. So setting that up is a lot more complex than just setting up Minikube. And so if you ever followed Kelsey Hightower, this is actually the hard way to Kubernetes. And those are the different steps to actually set up a highly available Kubernetes cluster by hand. And this is not something I really would enjoy doing by hand all the time. I actually tried that once, but it took a while to get there. So, and it's not only about the deploying. This is what I actually hate about demos. Typically, a demo starts by like, hey, how can we set up a Kubernetes cluster? But once it's up and running, it actually stops. And the hardest part, in my experience, is actually the lifecycle management following that. So how can we scale our Kubernetes clusters? How can we upgrade from one version to the other? How can we actually deal with all the failures if there is a node failure? To those of us that might sound very familiar, actually cloud services like Amazon Kubernetes service, they're actually doing all of this for us. They're taking care of the deployment, they're taking care of scaling, they're taking care of upgrading. Just in certain scenarios, we might not be able to actually use those services because we want to control them ourselves, because we want to have part of our cluster on-prem or other reasons. And so this is basically how can we figure out how to do lifecycle management by ourselves or independent of such managed services in the cloud. Still, clicking, clicking, clicking. Okay. We're stuck in our presentation. That's great. So the second challenge coming in here is that actually, typically the companies we see, they are not deploying a single Kubernetes cluster. They actually go in and they have multiple Kubernetes cluster because different teams might want different versions. Different teams actually want to control their own cluster. So the challenge up here for lifecycle management also is not just using a single cluster, it's for a bunch of different Kubernetes clusters up here. And the third point is actually how can we manage our resources? As mentioned, a typical scenario we see is that people, they have their on-prem cluster, but still the cloud, AWS, is a very compelling argument. Otherwise, we wouldn't have that many people here. And so the question is, how can we actually combine our on-prem cluster, but still use cloud instances to burst out our service if we actually need more resources? So what we really want is we actually want Kubernetes as a service, but on any infrastructure everywhere, and to be actually also able to deploy in like hybrid scenarios. So kind of this hybrid cloud as a service. And again, we not only want that for Kubernetes itself, we actually also want that for other services such as Kafka, Cassandra, HDFS. Why? Let us look at the typical CI/CD pipeline. So if we build like our developer platform, we typically have different services here already. So we have source control with GitLab or GitHub. We have Jenkins to actually build and test our code. Then we have some kind of artifactory, such as JFrog Artifactory or a Docker registry. And then at the end, we also need like a deployment platform where we're actually running our code. So we have something like Kubernetes, something like Marathon. We have some logging and monitoring services with Prometheus. So already here, just to build like a typical development pipeline, we end up with a bunch of different distributed stateful services. Another one, and this is because this is a project I'm currently working on, if we're actually trying to do data science, it's even more services. So on the left, we have our data, which we are trying to keep here, HDFS, Kafka, Cassandra. Then we have our interface for our data scientists, something like Jupyter or Jupyter Lab, Zeppelin. Then we need to do the actual training, so we need to manage large scale of distributed infrastructure, potentially with GPUs. We need to manage our models. We need to deploy our models to production. So again, we end up with a bunch of different distributed stateful systems we actually have to manage. The next question is probably, where's actually the difference between container orchestration and the service orchestration? How many of you have heard about the replica set controller inside Kubernetes? So in Kubernetes, you can basically say, I always want 4 instances of my pod up and running, and no matter what happens to our cluster, whether there are node failures, whether there are task failures, I always want 4 instances of my Nginx pod, for example. And this is actually being controlled by the replica set controller. So the replica set controller, it has a desired target state, and this target state is I want to have 4 pods up and running. And so it's always checking. Imagine that just being like an endless loop. So it's checking how many instances are currently running. There are 0 running, so I'm just going to start 4 more. And now I have 5 up and running, so that's more than my desired target state. So I actually have to go in and kill one. So it's actually very simple, just starting or stopping containers/pods. If we're talking about stateful services, the starting and stopping is not as simple anymore. So for example, if we talk about name nodes in HDFS, so name nodes in HDFS, they're basically the metadata server keeping track of all the file locations, and so they're very crucial to the cluster. So typically we have 2 of those, and now imagine both of them have actually failed at the same time. So our desired state is still we want to have 2 of those up and running, but currently there are 0 up and running. What do we have to do? We cannot simply, as in the container orchestration case, go in and actually start 2 of them. We have to go in, we first have to recover the state from the journal nodes, then we have to step in and actually bootstrap, then we have to potentially, if it's the first time, even format them. So there are a lot more steps involved to actually get to this target state of having 2 name nodes up and running. It's not as simple as just spinning up a container or killing containers here. And for that, we need a layer to manage all of that, to control all of that. And this is typically a state machine which knows what steps need to be taken to move from my current state to my desired state in this example. So what are the challenges if we want to do that? The first challenge is actually about cluster management. So the very trivial approach to deploy all those services is just taking up virtual machines. And I take the first 10 virtual machines, I spin up my Kubernetes cluster. I take the next 10 virtual machines, I spin up my TensorFlow cluster, and so on and so on. And what that typically leads to, if I don't have like a software entity managing that, first of all, my operator actually has to keep track of all that, which virtual machines are running which version, which virtual machines I need to update, especially if there are now security patches coming in for like kernel patches. And so this is one downside, actually a lot of administrative overhead. The second downside is also that we are actually wasting a lot of resources because like each of those virtual machines has like some slack space, and this is actually accumulating in the stack. And this was the original idea of Apache Missiles. So Apache Missiles is an open source project developed by UC Berkeley and Twitter originally to run the Twitter infrastructure. And now it's running the infrastructure of Twitter, Netflix, Airbnb. So a lot of companies having like very large compute clusters. And the vision here is to actually see the entire resource pool as like one big chunk of resources. And that's actually similar as with my laptop. In my laptop, I don't necessarily care on which CPU this is running right now. I only want that there's some CPU cycles dedicated to showing the slides. And actually, Missiles and therefore then also DCOS, they do something very similar for the data center. They basically take all the data center resources, and I can simply say I want 5 instances, 5 kubelet up and running, and I don't necessarily care on which node those end up. And yeah, this is actually the vision then of Mesosphere and Apache Missiles to actually abstract away the resources here. It doesn't matter whether I'm running on a cloud, whether I'm running on AWS, or whether I'm running in my own data center. I can easily migrate back and forth between those two scenarios. And the other flexibility I get, I can basically run everything on top. Because Mesos is taking care of scheduling all those resources between the different, we call them frameworks on top. All right, question is, why should we use actually Mesos here? Why not Kubernetes directly? Kubernetes has really come like a long way in terms of stateful services, but at least of right now, it's still challenging to run stateful services on Kubernetes. We're getting there slowly, but there's still a bunch of challenges out there. So I'm really curious how it's going to look next year at reInvent, but as of right now, there's still a bunch of challenges to run those stateful services on Kubernetes. Challenge 2, and that's actually what we mentioned earlier, is the lifecycle management here. So we want something similar what Amazon is doing for AWS is doing for us for all those services, managing them, keeping track, but we still want to be able to also utilize our resources in our own data center, potentially burst into AWS as a cloud. So we have worked together with a bunch of partners, and we kind of have this service catalog with all those different services, such as Kubernetes, HDFS, Flink, TensorFlow, and it actually gives me a very similar experience than using a managed service in the cloud. I can just deploy that with a single click, and then we have this lifecycle manager in the back, which is actually keeping track of those clusters. So deploying Kubernetes, what we saw earlier, becomes a single command, becomes a single button click even if I want to. I personally don't like those button clicks because it's not a reproducible deployment, but I can still do that either via CLI or also via a JSON file I've simply hit against an HTTP endpoint. Another thing we should actually consider is it's not only about the simple deployment, those steps here. Has anyone ever read what it takes to set up like a encrypted Kafka cluster? First, when I looked at the wiki page, that was about like 2 years ago, it was like 1.5 pages of simply setting up HTTPS communication between my Kafka brokers. And again, this is something which a software component can do much better, because if we do that as humans, we're probably going to do mistakes, and here we actually can put that all in like a single command. And as mentioned, it's not only about the deployment, it's actually about this entire life cycle. So how can we do recovery? How can we do replace failed nodes? how can we actually update from one version to the other. So yeah, how can we manage the entire life cycle of such kind of service? And here again, this is the example of HDFS, and that's actually the deployment plan. So plan basically refers to how do we get to our target state. And so this is kind of the recipe of how do we get from no HDFS cluster to our desired target state, having an HDFS cluster. And as you can already see, there are a number of dependencies here. I first have to deploy the journal nodes, then I have to deploy the name nodes, then the zookeeper failover controller, and then I can actually start deploying the data nodes. And typically in most organizations, this is like knowledge encoded by DevOps or traditional administrators. And I personally feel this is much better encoded into software. The only thing I should actually keep track here is this is implemented as a state machine. I've seen a lot of those scripts actually just being bash scripts. As we're talking about distributed systems, those bash scripts, typically they won't work, simply because there can be a failure at any point in time. So at the instance where I start deploying my name nodes, there might be a journal node failing, and I actually have to go back and first fix the journal nodes before I can continue deploying the other nodes. Next challenge is actually multi-tenancy. So in most organizations, we not only have one stack, we have different lines of business, each requiring their own instance, their own subclusters. For example, their own Kubernetes cluster. And so a typical deployment we see is that each line of business has its own Kubernetes cluster. There are a bunch of development clusters. And then there's potentially like a shared production environment where like certain production services which are shared between the lines of businesses can be run. And just as one example, that this is not just a made-up number, this is a slide from CERN, actually. And CERN, that was already last year, they were running over 210 Kubernetes clusters. Next challenge is actually how do we manage our resources? How can we do bursting? So we've seen a lot of data centers where we have a certain set of resources. And those people, they invested in their data centers, they want to keep them, but they still want to leverage the cloud, because at certain instances, they might actually need more resources. So end of month for like billing or analytics, they just need a lot more resources. So they actually want to be able to still utilize cloud resources and just burst into cloud resources. And so there again, this abstraction layer from Apache Missiles comes in, which is basically hiding those different resources and just bundling them into like one big pool here. So in the end, the summary, and I'll switch over to like a live demo if my internet keeps on working. Yesterday we were talking about individual containers. Today we talk about container orchestration. The future is actually going to be service orchestration, so not just individual containers, but stateful distributed systems we can run here. So as I have 2 minutes left, let's hope the internet now actually likes me. So here we have our DCOS cluster up and running. And this cluster is actually shared between, let me group that by region. So I have a bunch of AWS nodes here, and then I have like my own data centers with different zones down here. And this actually allows me to bring up also like different use cases, like for fault tolerance. I can say I want certain applications to be deployed in my own data center. I want other applications to be scaled into the cloud. And I can actually have constraints about that. What I mentioned earlier, that it's just all abstracted away, obviously there are still some constraints where I can say I want to run it either across different fault domains, I want to run it across different zones, that I don't necessarily go down with my entire service once a single node fails. If we look what's currently running on the cluster, I already deployed a Kubernetes cluster here. And if we now look, get nodes here, kubectl. I see we currently have 2 nodes. Let's actually see whether in the last minute we can extend that cluster to scale up to more nodes. It's going to be a bit challenging in this time, but let's see how far we get. So here, currently, I said I only have 1 kubelet. Let's actually go up to 3 kubelets. This is, for example, right now, imagine my team has grown. I have more team members using this Kubernetes cluster, so I actually need a larger cluster. So the first thing happened, this is the controller. So this is the controller managing this entire Kubernetes cluster. So it's also checking whether there are any failures, whether a node has failed, whether a task has failed, and it would actually go in and restart it. And now, as we have changed the desired state to say we want a total of 3 kubelets up and running, it's actually starting new kubelets to reach this desired target state. 9 seconds left, but already the first kubelet is up. Let's quickly check the command. It's not yet registered. Race against the time. But we already see the tasks, they are up and running here. They just haven't joined the Kubernetes cluster yet. And here we go. So the second kubelet is here. It's not ready yet, but it's being deployed and it's joining the Kubernetes cluster. Thank you very much for listening. Feel free to ask me any questions. Feel free to drop by our booth. Thank you.
Thank you so much, Jörg.